So this is a tree diagram probability with replacement. With replacement means once, in this example here, once a kid can pick that particular candy, it is being replaced. So in this problem here, in a box, there are chocolate candies. 10 are Milky Way, will represent this letter M. 4 are Butterfingers, and 10 are Snickers. A kid can pick twice with replacement. So create a tree diagram for this. So we're gonna have the total number of candies for this first. We have 10 for Milky Way. 4 plus 10 is 24. So the total here is 24. So just add everything all out. Now we are going to write down the 3 types of candies. So in the first pick column, we have our first pick column here. We have Milky Way M, Butterfinger B, and Snicker S. So we're gonna have first pick, we're gonna have here M for Butterfinger, and then we have here what's the next one? M for Milky Way, B for Butterfinger, and then S for Snickers. And then the same thing here on each of the branches for second pick, M, Milky Way, Butterfinger, and Snickers. So the same thing here, that is M for Milky Way, Butterfinger, and Snickers. We're not working on the second pick. So that is again Milky Way, Butterfinger, and Snickers. Okay, on the blanks here, we're gonna have the probabilities. So for Milky Way, what is the probability? There's 10 of them, so it's 10 out of 24. Yeah, so this is 10 over 24. For Butterfinger, that would be 4 out of 24. That's for that blank. And then for Snickers, we have 10 out of 24. Okay, so what's going on here is that on the there are 10 Milky Way out of 24 total candy. And then the kid picks Milky Way. So, and then whoever was in charge of the box, that person would replace another Milky Way. So on the second pick, what would be the probability of getting another Milky Way? It's still gonna be 10 out of 24. Why is it that it didn't change? Because it was something was put in back, and whatever's being picked, that the teacher is going to put in the same thing. So if the Milky Way was put in, then was picked by the kid, so the teacher will have to put in another Milky Way. So there's still 24 total, because whatever was picked, the teacher will put in the same thing. So it's still going to be 10 out of 24. Now, how many Butterfinger probability on the second pick? So for example, on the first pick, the kid picked Butterfinger, and then the teacher will have to put in another Butterfinger then. So what is the probability of picking Butterfinger the second pick? It's still the same, yeah? So that would be what? What's for Butterfinger? 4 out of 24. And then for Snickers, that would be 10 out of 24. So it's not going to change because, again, the teacher, whatever gets picked, the teacher will have to put in the same thing in there. So I'm just going to go ahead and write it down. Okay, so we are going to, again, all the numbers here do not change for each branch. So for Milky Way, it's still always going to be 10 over 24. 10 over 24 because, again, the reason for that is whenever the kid picks the Milky Way, then the teacher will have to put in another Milky Way, and then the kid can pick again. So the probability didn't change the first pick and the second pick. So for the results here, what are we going to do is, that would be Milky Way and Milky Way. So this is MM, this is MB, and this is MS. So what are we doing is we're tracing the tree diagram. So MM, MB, MS. The same thing here, BM. What does it mean? So this result tells us that the kid is able to pick Milky Way on the first pick and Milky Way on the second pick. This means that the kid is able to pick Milky Way the first time and Butterfinger the second pick. This is Milky Way the first time and then Snickers on the second pick. So that's what these letters mean. Now, what is the probability that the kid is able to pick the Milky Way the first time and Milky Way the second time? So what we need to do is to multiply these two numbers. So that would be 10 over 24 times 10 over 24. So that would be 100 over 576. And then we are going to reduce this to lowest term. So I'd like you to figure out what is the lowest term for 576. So the reduced form for this is 25 over 144. The next one here, so that is 10. So this is 10 over 24 times that is 4 over 24. So we're tracing the branches of the tree diagram. So 10 over 24 times 4 over 24. 4 over 24. So this is 40 over 576. So that would be 4 divided by 8 is, 40 divided by 8 is 5. And then 576 divided by 8 is 72. Okay, so I'm going to go ahead and multiply this one here. And we're going to reduce it to lowest term. So I'll teach you how to simplify fractions using this calculator so that it's easier. So this is what we're gonna do. What you press is this. First, we have 100 over 576. So how can we reduce this to lowest term using the calculator without having to figure out what's the common factor? So what you do is you type in 100, type this button right here, A, B / C. If you type that in, type in 576, it will give you the lowest term. So that is 25 over 144. Okay? So that's how you reduce it to lowest term, so it's easier. Next, have 40 over 576. So 40 over 576. And then if you hit this, it's going to give us the lowest form. So that is 5 over 72. And then we do the same thing. Okay, now let's go over the probabilities here. So what is the probability that a kid picks Milky Way and Butterfinger? So Milky Way and Butterfinger, so we're going to trace the MB. MB is 5 over 72. 5 over 72. First, Butterfinger and Snickers, so BS. We look for BS, so it is 5 over 72. What is the probability that a kid picks Milky Way and Snickers? So MS, Milky Way, Snickers, 25 over 144. Now I'd like you to figure out the rest of the blanks here. So let's write the answers here. Okay, so others are going to say, like, what does this fraction tell us? So if the kid can pick 144 times, so pick candies from the box for 144 times, 25 of those picks will be Milky Way and Snickers. This one right here, 5 over 72. If the kid picks 72 times with replacement, 5 of those picks will be Snickers and Butterfinger. So that's what this numbers is telling us. So that is how we determine probability using tree diagram with replacement.